A planet has an upper atmosphere albedo of 0.17. Radiation from the star it orbits strikes the side facing the star with an intensity of 1,370 watts per square meter. If there's no greenhouse effect, what would be the equilibrium temperature of the planet with space? Might be cold. All right, let's figure this out. So 1370, okay, comes from space, right? It comes from the star. This is watts per square meter. And 17% is reflected, right? So if we multiply by 1 minus 0.17, we'll get the amount absorbed, right? So this is the intensity absorbed on the front side of the planet at high noon, right? Okay, we can do this. 1370 times left parenthesis 1 minus, and that is 1137.1 watts per square meter on the front side, on the sunward side. Okay, now to figure out what it is all over the planet, right? The average, the intensity average is going to be that 11,371.1 is absorbed by the frontal area, which is just pi r squared, but it's going to be spread out over 4 pi r squared. That is, we absorb on a circle. We look like a circle to the star, but that is in fact by the rotation of the Earth and all this stuff, right? Spread out over the entire planet, which is 4 times as large. So basically, this is just dividing by 4. But that's why. So when you do it on an IB test, make sure you put all the stuff in there. So this means the average per square meter rate of absorption, day and night included, is 284.275 watts per square meter. Okay? And that, we can figure out the intensity of that on the average, right? Is going to be the power over the area, which is going to be emissivity sigma area, temperature of the planet to the 4th over the area of the planet, right? So the areas cancel out, right? So we end up with 284.275 equals, the emissivity we're just going to say is 1 times 5.67 times 10 to the minus 8th times some equilibrium temperature for the planet to the 4th, okay? So ultimately what I'm going to do is take the number on my calculator, divide by 5.67 times 10 to the minus 8th, which gives me a, whoops, whoa, what did I just do? I did something really strange there. Okay, that number divided by 5.67 times 10 to the minus 8th, which is a huge number, and now I'm going to raise that to the 1/4 power. And that's 266.09 kelvins. So that's one of our answers, right? And then to figure it out in Celsius, 266.09 kelvins minus 273.15. It's going to be below freezing, won't it? Minus 273.15 is minus 7.0536 degrees Celsius. So I guess we'd say minus 7.05 degrees Celsius. It's chilly. All right. Ta-da.